Today, I'm going to go over some practice problems with you from your homework assignment. So if you pull this up, you'll see a handout that says gram formula mass. Before we calculate the molar mass, we're going to practice with you on how to count the number of atoms in the formula. So we're going to start here with KMnO4. Remember, ones are understood. So right here you have 1 potassium because there is no number written beside 1. Potassium is understood to have 1 atom in that compound. For manganese, MnO4, there is 1 manganese. And if you look at oxygen, you have the subscript of 4, so you have 4 oxygens. So first, I'm just making sure you understand how to count the atoms. Following this handout, you will see that there's a handout, the same handout with the answers on it. Next, let's skip down to number 4 because numbers 2 and 3 work the same as number 4. So now we're going to take a look at a problem that includes parentheses. So here you have calcium nitrate. And so in algebra, you learned, or maybe just in math 1, you learned that whenever you have a 2, you distribute that through the parentheses. So we're going to apply that same concept to chemistry with this problem. Again, looking at, you have calcium, nitrogen, and oxygen. This right here, this polyatomic ion, is nitrate. So there are 2 ways we can look at this. You have 1 calcium. If you look at the nitrogen, inside the parentheses, you have 1 nitrogen. But if you distribute this 2 through the inside of the parentheses, you have 2 nitrogens. So once again, 1 calcium, you have distribute the 2 throughout the parentheses, so 2 times this 1 nitrogen equals 2 nitrogens. Distributing this 2 inside parentheses, 2 times 3 equals 6 oxygens. However, if we look at this compound and look at this polyatomic ion as a unit, you would also be able to see that there are 2 nitrates, all right? So you should be able to look at this in both ways, remembering that you cannot change the subscript. So there are always 3 oxygens on nitrate, but when we distribute through inside the parentheses, you have 2 nitrogens and 6 oxygens. Let's look at number 5. So as you look at number 5, if you look at aluminum, you have 2 aluminums. Distributing that 3 through the inside of the parentheses, 3 times 1 sulfur equals 3 sulfurs. You have 4 oxygens inside the parentheses, but when you multiply 3 times 4, you get 12. So once again, what happens if we don't break down the sulfur and the oxygen and we leave the polyatomic ion as a unit? Then you should see if sulfate is inside the parentheses, SO4, that lets us know that with that 3 on the outside of the parentheses, that we have 3 sulfate ions in the compound aluminum sulfate. Now looking down to number 7. With number 7, you have what is called a hydrate. So with this particular problem, it's the same thing that we've been doing previously. You have 1 copper, 1 sulfur, and 4 oxygens. Or you have 1 copper. But this dot right here, when we see this 5 and then water, we have 5 moles of water. And so right here, we know that this dot, and we have this water behind it, 5 moles of water, that lets us know that we have a hydrate, all right? So we have copper 2 sulfate pentahydrate. You all learned that the prefix for 5 is penta, and we have 5 water molecules, all right? So if we go to count the number here, we have 1 copper, we have 1 sulfur, there are 4 oxygens. So, again, in math, we will multiply this 5 times everything behind it. So you have 5 moles of water. However, when we break it down, you have 10 hydrogens because 5 times 2 is 10. And the same thing as you learned before, you have 5 oxygens. So 5 times 1 is 5. And let me go back and make a correction. I want to go ahead and erase this 10 as a subscript. I did not mean to write that as a subscript, so let me fix that. So you have 10 hydrogens. All right, last hydrate that we're going to practice. Let's look at number 10. You have 3 zincs. You have 2 phosphorus. You have 8 oxygens. Now, right here we have another hydrate. This is a tetrahydrate. So when we multiply 4 times 2, you get 8 hydrogens. I keep writing the same thing over. Okay, let me try this one more time. You have 8 hydrogens, and then 4 times 1 will give you 4 oxygens, all right? And so as you continue to practice these problems, you will see down below, immediately following this handout, are the answers to calculating the number of atoms for each one. Over here on the left, in the next lesson, I'm going to go over with you how to calculate the mass, all right? Make sure you practice and you know how to count the number of atoms before you move on.